It's been a long time coming, but NASA's Space Launch System, SLS, is finally ready for its maiden launch. And what a launch it will be! SLS will be carrying Orion, NASA's next-generation spacecraft, on a journey around the Moon. This will be the first time that Orion has flown, and it will be the first time that any human-rated spacecraft has left low Earth orbit in over 45 years. The launch of SLS Orion is a major milestone for NASA and the agency's journey to send humans to Mars. But it's also an important step for humanity as a whole. This launch could very well be the beginning of a new era of exploration, one that will see us ventured out into the solar system and beyond. The Artemis 1 mission is the first in a series of planned missions to send astronauts to the Moon and back. The mission is an important step in NASA's plan to establish a sustainable human presence on the lunar surface, and will lay the groundwork for future missions to Mars. This is Mira. In this episode, we will wonder how NASA has meticulously planned the Artemis 1 mission. We will understand its mission details, objectives, and trajectory. We will also know how important its success for future space missions. Artemis 1 will be the first integrated test of NASA's deep space exploration systems. The Orion spacecraft Space Launch System, SLS, rocket, and the ground systems at Kennedy Space Center in Cape Canaveral, Florida. This uncrewed flight will provide a foundation for human deep space exploration and demonstrate our commitment and capability to extend human existence to the Moon and beyond. During this flight, the spacecraft will launch on the most powerful rocket in the world and travel farther than any spacecraft built for humans has ever flown. It will stay in space longer than any ship for astronauts has done without docking to a space station and return home faster and hotter than ever before. SLS will be launching from Launch Complex 39B at the newly modernized Kennedy Space Center in Florida. This powerful rocket is designed for missions to the Moon and beyond, producing 8.8 million pounds of thrust. It will be propelled by a pair of 5-segment boosters and 4 RS-25 engines. The journey will reach the point of greatest atmospheric force within 90 seconds. After separating from the boosters, service module panels, and launch abort system, the core stage engines will shut down and the core stage will separate from the spacecraft. As the spacecraft makes an orbit of Earth, it will deploy its solar arrays, and the interim cryogenic propulsion stage, ICPS, will give Orion the big push needed to leave Earth's orbit and travel toward the Moon. From there, Orion will separate from the ICPS within about 2 hours after launch. The ICPS will then deploy a number of small satellites, known as CubeSats, to perform several experiments and technology demonstrations. While Orion is on its way from Earth's orbit to the Moon, it will be propelled by a service module from the European Space Agency. This module will provide the main propulsion system and power for the spacecraft, as well as air and water for astronauts on future missions. Orion will pass through the Van Allen radiation belts and fly past the GPS satellite constellation and communication satellites in Earth orbit. To communicate with Mission Control in Houston, Orion will switch to the Deep Space Network. From here, Orion will continue to demonstrate its ability to navigate, communicate, and operate in deep space. Orion will take a few days to reach the Moon, during which time engineers will check the spacecraft systems and correct its trajectory if necessary. It will then orbit around the Moon at a height of 100 kilometers, using the Moon's gravity to tug it into a new orbit 70,000 kilometers from the Moon. In this new orbit, Orion will travel in the opposite direction to the Moon's orbit around Earth. It will stay there for 6 days to collect data and allow mission controllers to assess its performance. Orion will fly past the Moon's surface at a distance of 60 miles, or 100 kilometers, and then utilize a precisely timed engine firing courtesy of the European Service Module, combined with the Moon's gravity, to accelerate back towards Earth. This will put Orion on a trajectory back towards Earth, where it will enter our planet's atmosphere traveling at 25,000 miles per hour, or 11 kilometers per second, and experiencing temperatures of around 5,000 degrees Fahrenheit, or 2,760 degrees Celsius. This is faster and hotter than what Orion encountered during its 2014 flight test. Orion's 4 to 6 week mission will cover 1.3 million miles and end with a test of the spacecraft's ability to return to Earth safely. If it passes, Orion will land within eyesight of the recovery ship off the coast of Baja, California. Divers from the US Navy and NASA's exploration ground systems will approach in small boats, inspect the spacecraft for hazards, and hook up tending and tow lines. The capsule will be towed into the well deck of the recovery ship. With this first exploration mission, NASA is taking the helm of the following phases of human space exploration. Astronauts will build and start testing the systems near the Moon that will be required for missions to the lunar surface and exploration of other planets farther from Earth, such as Mars. The second mission will test Orion's vital systems while carrying crew members and will follow a different course. From an initial configuration that can transport more than 26 metric tons to the Moon to a final configuration that can send at least 45 metric tons, the SLS rocket will undergo evolution. The ground systems at Kennedy, SLS, and Orion will be able to work together to accomplish the most difficult crew and cargo mission requirements in deep space. After the Artemis 1 mission, Artemis 2 will perform a crewed lunar flyby and Artemis 3 will perform a crewed lunar landing, 5 decades after the last Apollo mission. Keep wondering.